We mentioned up here in the last video about two items here, communication attacks and social engineering. And I just wanted to take a brief look at where those might occur. SMS services, MMS services, Wi-Fi, and Bluetooth are the ways that most of these occur. I should have included email perhaps in this list. All of those are communication attack types and typically would be social engineering kinds of attacks. All right, now we're going to look at a whole bunch of Android vulnerabilities. Now your book also gives you a whole bunch of vulnerabilities on page, let's see, 245 and 246. There's a table in chapter 11 that breaks it up into surveillance vulnerabilities, financial vulnerabilities, botnet activity, and data theft. And then impersonation. And that's a really good list. I have a slightly different list, so this is completely different from what you're going to see in the book. But I think that this list sums up pretty well most of the types of vulnerabilities that you're going to run into. And I'm not going to read through these one by one and explain every one. But I am going to stop at a few of them that might throw you off. You might not understand what they're talking about. Of course, we all understand about outdated software and malicious apps. And insecure data storage, this one refers to, for example, the person who goes to work, does a bunch of stuff at work, and then leaves the workplace with their phone and with a lot of data that belongs to the workplace. That would be an example of insecure data storage. Weak SSL and TLS implementations. SSL and TLS are communication protocols that help to encrypt communications. And if you have an earlier version, for example, of SSL or TLS that is not as secure as it used to be, then you have a vulnerability there. Privilege escalation, simply meaning, of course, somebody getting higher privileges. It could be through, for example, an application that's on the phone. Some of the apps that come with the phone have privileges to access contact lists, photos, things like that. And properly used by the attacker, they can use those applications to escalate their privileges to get access to those things. SIM card swapping, pretty self-explanatory. Insecure APIs. API stands for Application Programming Interface. And these are points in the software that you point to when you want the software to do something it already has the capability of doing. So for example, a print job, there's already a routine on how to print and you just give it some text and point to it so that you don't have to rewrite that. Well, that's what APIs are. They're a place in the software that you can access as a programmer. Well, if you can access them as a programmer, the bad guy can also access them as an attacker. WebView vulnerabilities. WebView is an app that's built into your phone that allows web pages to be seen inside of other apps. And so by rendering web page content in apps, if there's a form in that web page, you could then use that to upload code to the application and make it do something it's not supposed to be able to do. Here's one you may not understand right away. Time of check, time of use, erase conditions. What do we mean by that? Well, the phone intercepts requests for certain kinds of services. So for example, let's say that you check the status of the phone, and whether you have a connection in the phone or not. And normally that time of checking that status is very close to the time that the actual command is sent to it to do something. Well, if the time of use can be delayed far enough from the time of check, then the condition may not be the same as it was when it checked, and it may allow the application to do what it's planning on doing when the service was not in the right state. We call it a race condition because it's racing to see if the time of check can be fast enough to truly keep into check what the time of use of that command is. I hope I described that well, but it's a little bit complicated at first to understand. Excessive permissions, of course, some apps, especially built-in apps, may have permissions to things that you don't want the attacker to have permissions for. We all understand phishing attacks by now and Bluetooth exploits and Wi-Fi eavesdropping. Rooting, which is simply altering the device's operating system to bypass some of the security functions. Adware and spyware we're familiar with. Sideloading apps, sideloading risks has to do with loading apps that do not come from the official Play Store or App Store. Insecure backup mechanisms. If we don't have good backup, then our sensitive data may be exposed. Code injection is a little bit like what we talked about up here in WebView vulnerabilities, injecting code where you're not supposed to be able to put code, for example, in a web form. And then rogue baseband attacks has to do with the cell system. In this case, it turns out that there is a special microprocessor on the phone whose job it is to process connections between the app and the cell system. And this is an attack on that microprocessor or its services. All right, that's it for these 20 or so types of vulnerabilities that you might find in an Android phone. We're going to look at these again in the iPhone, and we'll see slightly different list there.